So last class, we had started to talk about the exponential function graph. And while we haven't really actually started graphing, we are going to get into that today. But we started talking about the transformations. So we learned about the parent function and the and we outlined all of the different transformations. So horizontal stretch and compression, vertical stretch and compression, reflections, and then the translations. And like I told you guys last class, luckily, because we've already done an entire unit on transformations, this stuff hopefully is a little bit more review and it's coming more naturally. We did question number 1, where I gave you guys a parent function of f of x is equal to 2 to the power of x, and then we went through all the different transformations. And then we did question number 2, where again, I had given you an equation with a bunch of different transformations, and we went through all of the different words and things like that. So we're just going to continue on with this. If you take a look at the rest of the sheets, question 3, we're just going to do more of the transformation stuff. Then we're actually going to get into graphing. So that's our goal for today. So let's start with question number 3. Question number 3 says, determine an equation for the following transformation. So this time I'm telling you the transformations in words, and we're going to take those words and change them into an equation. So f of x is equal to 1 over 4x. This is our base equation. So there is no stretch or there's no transformation to this. This is what we call the base function. Okay, and so 1 over 4 to the power of x needs to definitely be included in our answer. It is vertically stretched by a factor of 3. So just visualize where you think that number will go. It's a vertical stretch, so it's probably going to go in front of the base. It's reflected in the y-axis. So reflected in the y-axis means it is a vertical reflection like this, up and down. And then it's translated 5 units to the right. So again, that is a horizontal translation, 5 units to the right. Okay, so if I were to write down the different transformations from this, I would first start with f of x is equal to, and I know the base function is 1 over 4x. Now we might have to change this around a little bit, but let's just get started with writing that down. Vertical stretch by a factor of 3 and reflected in the y-axis, both of those are going to go in front of the base. So we're going to have -3 over here, right? The negative means it's reflected in the y-axis, and the 3 means it's a stretch. I lied. Reflected in the y-axis means like this. Yeah, I actually just thought about that. It should be negative up here because it's actually a horizontal reflection. And then it's translated 5 units to the right. Now, whenever you're writing your own formula, you guys have to remember to write it in factored form because it makes the question a whole lot easier. So in order for me to show this, I know there has to be a negative here, and then in brackets, I'm going to write x minus 5 to show that is translated 5 units to the right. That would be your final answer. If you wanted to rewrite it so that the negative is distributed, that's fine as well. Yes. For question B, we have f of x is equal to 11x. So again, this is your base function. It's not an actual transformation. It's horizontally compressed by a factor of 0.25. Okay, so let's break that down a little bit. 0.25, if I were to write that in a fraction, it would be 1 over 4. And a horizontal compression means it's going to be in our exponent, but we're going to do the opposite. So we're not going to actually think of it as 1 over 4. We're going to think of it as the number 4. Okay, so we'll keep that in mind. Vertically compressed by a factor of 0.75. Again, let's just change that to 3 over 4. That's a personal preference. You can keep it as decimals, but I like fractions a little bit more. It's reflected in the x-axis, so now we have a vertical reflection, so that negative is going to go on the outside. It's translated 2 units to the left, and it's translated 4 units up. I'll give you guys 30 seconds to go ahead and try this. Okay, so we begin with f of x is equal to, and at some place, I'm going to have my base of 11, and then it's going to be to the power of x. Now we're going to add on to this. So what did you guys put in front of the base 11? You put 3 over 4, yep. And anything else if it's reflected in the x-axis? Yeah. Yeah, so I have -3 over 4 in front. Those are both the vertical reflections. Did you put anything all the way in the c value, like all the way at the end? Bea? Yep, because it's going 4 units up. So all the way at the end, I have a +4. And now let's figure out the horizontal transformations. So we have a horizontally compressed by a factor of 0.25. We're going to change that to the number 4. And then there's also a translation 2 units to the left. So the way I would write that is I would write 4 and then bracket x plus 2 to show that it's moving 2 units to the left. Now we have a horizontal compression by a factor of 1/4 in the 4, horizontally compressed by 3/4, reflected in the x-axis, translated 2 units to the left and 4 units up. So this should be our final answer. Yep. So question number 4 says, graph each function, show all your calculations with mapping notation, use a minimum of 5 points, state the domain, range, y-intercept, and equation of the asymptote. So whenever I'm doing a question like this, the first thing I want to do is I want to identify what the base function is. And I just look at the big number that's attached to the exponent. In this case, our base function is going to be f of x is equal to 3 to the power of x. And that is what our parent function is going to be. That's what we're going to start off by graphing. So just like before, I'm going to have just x and y. And if you're wondering, is there anything special to graphing this? No, the values I use are -2, -1, 0, 1, and 2. So let's use those. -2, -1, 0, 1, and 2. Now you are dealing with exponents, so if you wanted to get a rough sheet of paper to do the calculations, you could. I'll just show you a couple of them just on the side, and then the rest we can just do in our head. So the first one is 3 to the power of -2, which is going to be 1 over 3 squared, which is going to be 1 over 9. So here we're going to have -2 comma 1 over 9. The next one is 3 to the power of -1, which is just going to be 1 over 3. So this is going to be 1 over 3. 3 to the power of 0, anything to the power of 0 will be just a 1. And then if there's not a negative exponent, it's pretty straightforward. 3 to the power of 1 is just 3, and 3 to the power of 2 is just 9. Now think back to last class. If this is just like a regular old function, where should the asymptote be? Yeah, so let's go ahead and graph this, and we're going to put an asymptote at y is equal to 0. So hopefully you guys have rulers and you can use a ruler to draw a dashed line. And then I'm just going to label this horizontal asymptote y is equal to 0. And I'm going to start off by graphing my parent function f of x is equal to 3x. So just do that super carefully and see what you get. When it's a parent function with no transformations, yeah, it's always y is equal to 0. All right, now we're ready to graph our transform function. So the first thing I'm going to do is I'm going to recognize that this function is not in factored form, and that is a really important step. So we're going to factor it by taking out the negative, and it's going to be x minus 2. So f of x is equal to 3 to the power of negative x minus 2. Okay, when we're doing our mapping coordinates, there seems to be only horizontal transformations here. So only our x is going to be affected. And does anyone want to venture a guess as to what our mapping coordinates would be for the x? Sarah? Yep, it'll be negative x plus 2, comma, just a y, because nothing changes in the y. So now, just like before, you're going to take every single one of your x values and put them into x and then solve. So negative minus -2 is 2, 2 plus 2 is 4, so this is going to be 4, comma, 1 over 9. Minus -1 is 1, 1 plus 2 is 3, so this is going to be 3, comma, 1 over 3. Then I'm just going to keep going. This is going to be 2 comma 1. Negative 1 plus 2 is going to be 1 comma 3. And negative 2 plus 2 is just going to be 0 comma 9. Is there a number in your C value to change the asymptote? No, because there's no vertical translation, the asymptote will actually still stay at y is equal to 0. So we can keep that there, and all we're going to do is graph the new function. Bea? Yep. The original. Yeah, it does end up being the same. But it would, yeah. Because when you're actually describing the transformations, it will not work if you use the unfactored form. Yeah, yeah, yeah. And this was also the case in the other functions that we used to do. We factor it, but really when you're doing the mapping coordinate, it's just the unfactored. Yeah, yeah. Which is kind of nice to double check your work with. 2 comma 1, and then 1 comma 3, and then 0 comma 9. So then we have our new function that looks something like this. Make sure you guys have arrows on both ends, and then make sure you also label your function f of x is equal to, and when you're labeling the new function, it doesn't matter if you use the factored or not. So f of x is equal to 3 to the power of negative bracket x minus 2. For our questions, we're only going to be answering them for the transform function. So we don't need to worry about the domain and range for the original. So I'm just going to write transformed up here so we know. What is the domain of the transform function? It would just be x includes all real values. What is the range? Yep, so it would just be y is greater than 0 because it does not actually touch the 0. The equation of the asymptote we have already decided is y is equal to 0. And if we can read the y-intercept from the graph, we should, and we can. It's actually a point on the graph, so our asymptote would just be at 0 comma 9. If we were unable to read it, then we would do the calculation, let x equal to 0, and solve. Okay, 2 more examples of graphs. So let's just get right into the next one. We have f of x is equal to 4 bracket a half to the power of 2 bracket x plus 3. This is already in factored form. What is the parent function in this, or the base function? Try again. Yeah, it would actually be 1 over 2 to the power of x. The 4 is actually a stretch. It's not the base function. So we're going to have x comma y. The numbers I pick are negative 2, negative 1, 0, 1, and 2. Okay, again, be careful with this. If you need to go on another piece of paper, you should. So for the first one, it's going to be a half to the power of negative 2. So I know when I have a negative exponent, I can flip the numbers around and make it 2 over 1 to the power of 2. You know that little trick where you take the reciprocal and change. And so 2 over 1 to the power of 2 is just 4. Negative 1, half to the power of negative 1 would just be a 2. Anything to the power of 0 is just a 1. This would be a half. And this would be 1 over 4. I pick those values. You guys, do we have a vertical translation in this parent function? Just in the parent, like a, yeah, nope. So our asymptote is going to be at the same as before. It's going to be at y is equal to 0. Okay, now for the transformed, we have f of x. We actually don't need to do anything to this. It's already like in perfect factored form. So it's going to be 2 bracket x plus 3. What do you think the mapping coordinates are going to be? Be careful because the 2 is actually going to switch around. So for the x, we're going to write, what do you guys think? Marzu? A half x minus 3, perfect. And then how about for the y? Marzu? Yeah, it would just be 4y. The reason we did this is because remember, anything in the exponent switches around. So if you have a 2 in the exponent, it's going to become a half. If you had a positive 3, it would become negative 3. It becomes a half, like you take the reciprocal, and the positive 3 would become negative 3. Okay, now we're going to write down all of our values. So we'll do the work. It'll be negative 4, comma 16, which we will not be able to graph. Negative a half minus 3 is just negative 3.5. Comma 8. This would just be negative 3, comma 4. A half minus 3 is going to be negative 2.5, comma 2. And this would be negative 2, comma 1. Okay, really carefully graph all the fractions and all the stuff. Oh, I didn't even graph my parent function. Sorry about that. So negative 2, comma 4, negative 1, comma 2, 0, comma 1, 1, comma a half, and 2, comma a quarter. Hopefully you guys can see that really for the fractions, you're just estimating as close as possible. So this is my parent function, and it is f of x is equal to a half to the power of x. And now my transform function, negative 4, comma negative 16, we can't graph. So negative 3.5, comma 8 would be like approximately here. Negative 3, comma 4 would be there. Negative 2.5, comma 2 would be there. And negative 2, comma 1 would be approximately there. Okay, and then that's my transform function. I'm just going to label it at the bottom over here. F of x is equal to 4. I feel like I'm going to run out of space. Let's squish this in a little bit more. F of x is equal to 4 bracket a half, and then 2x plus 3. All right, so we're going to do the domain for the transform function. It's just going to be x includes all real values. The range, the asymptote is 0, so it's going to be y is greater than 0. And then for the y-intercept in this question, are we able to calculate it or from the graph accurately? No. So unfortunately for this, we're going to have to do a little bit of work. We're going to let x equal to 0 because we have the equation. We're going to put x is equal to 0, and then we're going to solve. So I'll show you what that looks like. It's going to be f at 0 is equal to 4 to the times a half. So f at 0 is equal to 4, and then the base is a half. And then when I put in a little 0 there, it's just going to become 0 plus 3, which is 3, and 2 times 3, which is 6. 2 to the power of 6 is 64. So this is going to be 4 times 1 over 64. And then when I reduce this, it's just going to be 1/16. So therefore, our y-intercept is going to be at 0, 1/16, which is so small that you cannot accurately graph it. But it makes sense. If you look at my line, even though my line kind of looks at a half, it's not the most accurate, but your line should hopefully be like very, very close to the x-axis. Bea, you had a great 12 year. All right, so what is the base function for this graph? Good, it's going to be 1 over 3x. Oh, you guys, I can't get this right. It's really bothering me. I do it one more time. Okay, that's good. Then we're gonna have x comma y. We're picking our x's, so it's gonna be -2, -1, 0, 1, and 2. I feel like the fractions here are gonna get a little bit messy because the number is kind of weird. So 1/3 to the power of -2. 1/3 to the power of -2 is the same as 3/1 squared, which is gonna just be a 9. That was easy. 1/3 to the power of -1, that will just be a 3. 1/3 to the power of 0, that will just be a 1. 1/3 to the power of 1 is just going to be a third. I guess that's the messy fraction. And 1/3 to the power of 2 is going to be 1/9. And by the way, just like before, be really careful with the original, because if you get the originals wrong, then the rest of your graph, everything else is going to be wrong. So like double and triple check just to see if you made any mistakes. Our function is already in perfect factored form, so we don't really have to worry about that. What will be our mapping coordinates? So what will be attached to the x? Yes, not a half, but a 2, because we switched the half to a 2. And then for the y, yeah, sorry, what did you say? Okay, so it's going to be -2y minus 4. Now, does this graph have an asymptote? Sorry, an asymptote that's different than y is equal to 0? Yes, it does. How do we figure that out? Well, this number actually represents where the asymptote is going to be. So we are actually, just to make things a little bit less messy, I'm not going to draw the original asymptote of y is equal to 0. I know it's there. I'm only going to draw the transformed asymptote. And if you guys were to do that, that would be perfectly fine as well. If you want to draw both the asymptotes, that's fine as well. So I'm going to just draw the graph of the original function, which is going to be -2, 9, -1, 3, 0, 1, 1, a third, and then a 9. And I know, even though I'm not drawing the asymptote, there is definitely one at y is equal to 0. Okay, so this is our original function. F of x is equal to 1/3 to the power of x. Now for the new graph, before I do anything, I'm gonna go ahead and just draw my asymptote. So at y is equal to -4. We're gonna have our new horizontal asymptote at this point. The quick way to figure this out is you just look at your equation, whatever number is over here, like in the C position, that is your asymptote. Yes. It's a 0. Yeah. Which is why then you can just draw the asymptote for everything. All right, we're going to do all the math. So 2x, this is going to be -4. This is going to be -2. This will be a 0, 2, and 4. -2 times 9 is -18, 19, 20, 21, 22. So this will be way off the graph, but it is a point. -2 times 3 is -6, minus 4 is -10. We can definitely draw that. -2 times 1 is -2, minus 4 is -6. Okay, so -2 times a third is -2/3 minus 12/3, which is -14/3. I'm going to make that into a mixed fraction of -4 and 2/3. And then the same thing with the 1/9. You're probably going to have to do a little bit of work on this. -2 times 1/9 is -2/9 minus minus 36/9. So this will be -38/9, which is the same as -4 and 2/9. So just a little bit of fraction work to figure out what those points are. So let's keep going. We're going to now graph the transform function. So -4, -22, I can't graph. This will be here, 0, -6 will be there. 2, -4 and 2/3 is approximately there. And honestly, once you put in your asymptote, you can clearly see which way the points are heading towards. So it really makes it a lot easier to do these graphs. And that's why whenever I see an asymptote, that's the first thing I do. I go ahead and draw that in. I feel like I can do a better job with this line. Okay, that's good. And then I'm just going to label my function. So this is going to be f of x is equal to -2 bracket 1/3 a half x minus 4. Off. So what is the domain of the transform function? It still extends to the right and to the left. So it's going to be x includes all real values. However, this time our range is different. So for the blue graph I have up here, you can see it has to be below -4, but can it touch -4? No. So our range is going to be y is less than -4. If you put an equal sign, the entire thing is wrong, because then you're really not understanding the idea of the asymptotes. So be mindful of that. We know we have an asymptote at y is equal to -4. And is our y-intercept really easy to see here? Yep, so we don't need to do any calculations. It's just going to be 0, -6. Not too bad, right? All right, let's finish off the questions 5 and 6, and then you guys can have time to work. I don't think anyone still needs this. All right, question number 5. How are these functions related? So I really just wanted to draw your attention to the stuff we did in the beginning of the unit. You're allowed to change functions and write them differently. So here I have f of x is equal to 2 to the power of 2x, but we can actually rewrite this and write it as g of x is equal to, the number 4 can be rewritten as another power. So what can we replace the 4 with? 2 squared all to the power of x, right? So remember how we kind of did this in the first lesson where we were replacing the number like 25 with 5 squared? We're doing the same thing now. And when you just simplify this, it gives you 2 to the power of 2x. And that's why f of x and g of x are the same function. They're related because you can actually rewrite them as either or. Let's do the same thing with question B. So we have f of x is equal to 3 to the power of 2x plus 1. And then we have g of x is equal to 3 times 9 to the power of x. It doesn't seem like they're related at all. But if we kind of do the same thing that we did in the previous question, we have g of x is equal to 3. I can replace the 9 with 3 squared all to the power of x. This is like saying 3 to the power of 1 times 3 to the power of 2x. And then when you have the same base and it's multiplied together, you can add the exponents. So you're going to get 3 to the power of 2x plus 1, which is the same as f of x. So if I gave you a question like this and I would say, how are they related? You're basically trying to change one of them to look like the other one. This question. So question number 6 is saying, rewrite the following functions in the form f of x is equal to a bracket b to the power of x plus c. So basically, they want you to rewrite this so that you only have one base to the power of x. You want to kind of get rid of all the stuff in the exponent. Initially, this question does look a little confusing, so I'm going to walk you through it and I'll tell you my strategy for question A, and then you can try question B. So I have f of x is equal to, I have a big number 4, which would have been a vertical stretch. And then do you guys see how we have 2 all to the power of 3x plus 1? I'm going to rewrite that and I'm going to split it up. And I know that in order for me to have gotten an exponent where 2 things are added together, originally they must have been multiplied together. So see if this makes sense. If I write it as 2 to the power of 3x times 2 to the power of 1. Can you recognize that this gives you this? So pause here and see if that makes sense. Does that make sense? Remember, when you have the same base and they're multiplied together, you're adding the exponent. So now we're just working backwards. If I have exponents that are added together, I know I multiplied them to get that. Okay, so that's usually the first step that you're going to do to solve a question like this. And then we have a big minus 7. So I'm just going to write this again so it's a little bit neater. Times 2 to the power of 1 minus 7. Okay, now I have 2 to the power of 1, and then I have a 4. So what I can do is I can actually take this, and I can take this, and I can multiply them together because everything in this term is multiplied. So I'm going to do that, and I'm going to end up getting 8 times. I'm also going to rewrite 2 to the power of 3x to look like this. 2 to the power of 3 all to the power of x. I haven't really changed the value. I've just taken the exponent 3x and I've split it up into 3 in the bracket and x outside the bracket. And the reason I did this is because now look, I'm going to have 8. 2 to the power of 3 is just 8x minus 7. And that's sort of what the question was asking you for. It's asking you to take the original function, the transform function, and change it so you just have one base to the power of x. This can be confusing because it has a lot of steps. I want you to try question B. I'll give you maybe 2 minutes to try it, and then we'll take it up. But honestly, the steps are going to be pretty much exactly the same. Yeah. Let's do this last question. So for this, I'm going to have f of x is equal to, I have a -1 times, I am going to actually, before I do any of this, rewrite it so that I distribute the exponent. So it's actually going to be f of x is equal to -1/2, and then this is -2x plus 6 plus 21. Okay, now we can get started. So f of x is equal to -1 times, this is going to be 1/2 minus 2x times 1/2 to the power of 6 plus 21. F of, did I say it is 1/2? No, because we're not actually doing any transformations or anything. We're just distributing the -2 inside the bracket. So nothing changes. 1/2 to the power of 6, we already did this. It's going to give you -1/64. Last question. Oh, so nice. And then this is going to be, wait, 1/64. And then I'm getting 1/2 to the power of -2 on the inside, all to the power of x. So I guess I can write that as 1/2 to the power of -2, all to the power of x plus 21. And then when you do the work here, you actually just get -1/64. This will become 4 to the power of x plus 21. Do you guys get that? Okay. Yeah, because see the -2 times x, I want to split it up. So there's just an x on the inside and outside, and I bring in the -2 to the 1/2. 1/2 to the power of -2 is a 4. It became 1/64. Yeah. Okay, so I'll let you guys think about this for a little bit. Your homework questions are on the bottom left-hand